Yeah, that dry aged steak is going to be my present for myself for doing this talk, so hopefully it turns out okay. Thanks for having me, and this is really exciting for me to talk about Pickle. Fun fact: this is our team's first time to have the chance and talk about Pickle in person, so it's a great fun moment for us. So without further ado, let me go ahead and pull up my slides and okay, bad gateway. Did I set up the ports correctly? Probably was the bad config. Man. All right, well that's it. Yeah, we can all just go home now and let you guys get an extra hour. If only we had something like Pickle to solve the day. It's like we do. So yeah. So today I want to introduce Pickle and kind of introduce it in high-level terms, but I want to spend most of the time in the editor and showing you what it's like to use Pickle. I'm going to have about 10 minutes worth of content, and then I'll have about hopefully 30 to 35 minutes of me demoing. And then as I'm demoing, if there's any questions about the code that I'm writing, then please do speak up, because if you miss something, it's all contextual and it all builds on each other. And if you miss something, then it's kind of important that I make sure that you're not missing and just kind of losing me through the rest of the talk. Quick note about me. I'm, like Julie said, I'm one of the core maintainers of Pickle at Apple. And it's a pretty small team. There's 3 of us maintaining Pickle, but it's a great group, and I think we've done some pretty awesome things throughout the years. I live right here, across the bridge in Oakland, and if you're here in the area and you want to, learn more about Pickle in person, then feel free to hit me up. And I've noticed this is a common theme among speakers. I'm an ex-musician, and I went into tech by kind of meandering through the musician lifestyle and getting a degree in music performance, and then suddenly realizing, oh, I really like programming. And then I got really obsessed with it and kind of been doing it ever since. As far as tech, I've kind of been all over the place. I've spent a bunch of my time doing services. I've also done apps. I've done iOS and Android. I've been a DevOps engineer, and I've kind of worn every single hat that you can wear, including being a designer for some reason. And one of the things that I've done in the past that was also language related is I used to design children-oriented programming languages, which is not object-oriented, it's not functional, it's this stuff. It's something meant for a kid between 5 to 8 years old to 13 years old to learn how to program. So this is the Google Trends result for the search term infrastructure as code. And on the vertical axis, what you'll see is plotting the frequency of the search term, where higher on the plot is more frequent. And then on the horizontal axis is the search term over time. So what this is telling us is infrastructure as code is kind of how the industry as a whole is kind of coalescing for how to manage infrastructure. And if you're not familiar with infrastructure as code, it generally looks something like this. Usually it's, the code is YAML. You write a bunch of YAML, and then you check it into GitHub or some other source code repositories, SVN system. And then you check that in, and then you provide that, you apply it to some sort of engine somewhere that takes this and then takes what you're declaring, and then poof, you get infrastructure. And this is a made-up example, but I think if you're familiar with infrastructure as code, this might look kind of similar to the things out there. Here we're declaring, I want 2 machines. I want a machine in the US West region. I want a machine in the US East region, and then here's all the properties about the machine that I want. Here's the environment variables that I want. I want this many CPUs, this much memory, here's how to configure the health check, et cetera, et cetera. And this has been amazing. This is something that has allowed us to really improve the velocity of changing configuration, changing infrastructure over time. It's simplified deployments quite a lot. And one of the things that comes with this is eventually your configuration will grow in complexity. And it can grow in complexity in two ways. It can either grow it can scale in complexity of logic. It also can grow in complexity of how much configuration that you're describing. And so we've already started down this path. We have this format, it's YAML, and we have this problem that we need to somehow scale our system. And so often what you see is something that looks like this. So we have our engine. How do we solve this? We have YAML. Let's go ahead and go with YAML. So let's come up with a new property called $imports, and this accepts some sort of relative path, m/prod.yaml, and we'll just look for that file at that path, and we'll load it in, and then we'll have our custom rule for how to merge that into our config. And then we can follow this, this line of thinking, and as more requirements come up, we can add more to our system. So maybe we need to create some parameters for our system. So we'll have, we'll have $params. Then this also accepts some sort of relative path, and this is how you create different machines based off of different things. And then maybe we need to differentiate the number of CPUs depending on whether we're deploying to production or some other environment. So we can keep following this path and go and create more rules entirely within YAML. And the thing about this is, if you take a step back, you start to realize this is actually a programming language. We've just invented a new language for our system. It just happens to be one that's kind of hard to understand, kind of hard to write, and it's bespoke to this one system. So I want to propose that this is driving in the wrong direction. As you scale down this path, and as you evolve down this path, you create things that are ad hoc. My product describes complexity this way, but another competitor might come out with their own way to manage complexity, and as a team that uses both products, they'll need to context switch between one thing and another. And this causes a lot of mistakes to be made easily. For example, as far as the language is concerned, you've invented a new language, but the core underlying language is still YAML, and YAML doesn't know anything about what you're doing here. One of my examples is there was this interpolation syntax with these brackets. And as far as the editor is concerned, if you're in VS Code or you're in IntelliJ, it's just a string. It's also hard because I need to context switch how I manage the complexity from one thing to another. Another thing that's hard is, as I describe my configuration, I want that to be valid. Because we're describing data, that data needs to be valid. If I say that the CPUs that I'm deploying is 10 million, then we have a problem, right? There's a great quote from Brian Getz, who's one of the Java architects over at Oracle. He tweeted this saying, "Every declarative language eventually becomes a terrible programming language just without the aid of actual language design." And just to clarify, this is talking about static declarative languages. So we want to flip this around. What if instead of starting with YAML or JSON or some ad hoc format, what if we start with a language? What if we build this language with solid principles that let you catch errors that lets you build abstractions easily, and then you use that same language to describe the data. And we found that this works really well. That's what Pickle is. Pickle is two things. It's both a programming language and a configuration language. And you'll see what I mean later when I go into my demo. It's a programming language in that you have all the same facilities that you have in a typical language. Like you have functions, type annotations, you have imports. It's a configuration language because that's what it's meant to do. It doesn't have things that are scoped beyond configuration. For example, it doesn't have an event loop, so you can't have async and wait APIs or something like that. So that's kind of the overview of Pickle. And then I think the best way to learn about a new language is kind of to see somebody writing it. So that's what I'm going to do, and this is going to be a live demo, and hopefully it goes well. Okay, so I'm switching over to IntelliJ. Here, I have an empty file. Oh, by the way, before I get into this, we have IntelliJ, but we also have an LSP. We also have plugins for VS Code, for NeoVim, and then if you have some other editor that you like, if it supports the LSP, then you can get Pickle support in there as well. So, okay, going back to this. So this is an empty Pickle file. This is tour.pickle. I have the Pickle plugin installed, and this is an empty object. So you can kind of think of Pickle files as, like, if you use the JSON analogy, as an object that has an implicit open curly brace, an implicit closing curly brace, and then you declare properties inside. For example, I can say foo equals 1, and then I have my shell open right here, and I can go ahead and eval tour.pickle, and I'm going to produce this in JSON. So Pickle is a language that evals into a static format. That's just one of the things, but it does more than that, but I'll get to that. I can have this output in XML. I can have this produce YAML andplists. And then you can also extend Pickle to produce other formats too. So we have foo equals 1. We can say bar equals foo. So foo's not just a property, it's also something that can be referenced. So foo is 1, bar is foo. And let's go back to JSON. So now we have foo and bar that are both the same thing. And then you can have nested objects. So here's a nested thing. Prop equals 1. And now we have a nested thing. And this is kind of what we, one of the concepts that drives how we think about Pickle and how we want to design Pickle is to have it closely model the target configuration so that when you read a Pickle file, it looks like the thing that you're targeting. Like if you're describing Kubernetes, for example, you don't have to guess what that means. Now I want to jump into the kind of what it's like to use Pickle. And earlier in my slides, we had this. We had my made-up IO infrastructure as code system. And I want to show you what it looks like when you use Pickle to describe this rather than YAML. And one of the concepts of Pickle is you want to describe the schema of the system. And then once you have the schema, then you can provide the data. So let's go ahead and do that. So I'm calling this foobar system. And then let's take the YAML and let's figure out what it looks like as Pickle. So we have machines, so that's a property. And we can go ahead and declare a property. But in this case, instead of providing a value, because I'm describing the schema, I'm just going to provide a type annotation. Machines happens to accept a YAML sequence of objects. And in Pickle, the way that you describe that is to say this is a listing. This is a listing of something. In this case, let's call it machine. And now that we've described this top-level machines thing, the editor has told us, I don't know what machine is. And then we get some editor hints in here. So let's go ahead and fill it out. So machines is also an object. So we'll call that a class. And the region is a string. We can actually do a little better than that. Here, let's assume that region is a closed set of strings. We only have so many regions. We don't have US West 3. We don't have US South or US North. So in this case, we can just say this is US West or US East. And this might look familiar if you come from TypeScript or maybe Scala 3 or other languages that have union types. Then we have environment. And these are environment variables. This is an arbitrary map of string to string. So in Pickle, we'll say this is a mapping of string to string. Next, we have CPUs, which is an int. And earlier I said maybe it's not valid if we want to create a machine with 10 million CPUs. So we can actually say, this is an int where this is less than, I don't know, 64. Let's go with 64. And what I'm doing here is I'm creating a type that has a constraint on it. And this constrains the set of possible values that you can provide to CPUs. I'll also say this is a uint, because maybe negative CPUs doesn't make sense either. One more example. The next thing is memory. Memory over here is a string. But in Pickle, we can do a little better than that. We can say memory is a data size. And data size is a primitive that's built right into Pickle. And what this means is you don't need to guess how that system represents 4 gigabits. Because you don't write a string, you write you use the primitive that's built into Pickle. So I'm going to skip ahead, and I'm going to show you what it might look like in an actual code base. Typically, you would take a little bit of time and make this somewhat polished so that when you later use this, it's clear to your developers what all of these things mean. I'm going to go ahead and copy and paste that to here. And then I'm going to blast through the rest of this real quick. So we have CPUs. Here I said it's a uint8. And then we have health checks. Health checks has a port. That's a uint16. The type is, again, it's a string literal union. And then the interval on the YAML side, we have 5. What is 5? I don't what does that mean? In Pickle, we can say this is a duration. And again, that's a primitive type within Pickle. And then finally, we're going to say the output of this module is YAML. And then when you encounter a data size, this is how you should turn that into YAML. When you encounter a duration, this is how you should turn this into YAML. And in this case, we're turning it into, let's say a data size is turning into a string, duration is turning into an int. So one of the analogies that you can kind of use to think about Pickle is when we defined this, we've just defined a form. And then when we define the data, we're filling out that form. So let's go ahead and do that. So here's another Pickle file, my config, and it starts with amends foobar system. And amends is kind of the secret sauce for a lot of how Pickle works. Amending says, I'm an object that is like this other thing, except with more things. In this case, the other object is foobar system. So let's go ahead and fill out the form that we just defined. So this has a top-level property called machines. And as I fill this in, I know what everything means. And this accepts two. I want to declare two machines. The first one, the region is US West. The environment has HTTP proxy. And I'll go ahead and copy and paste. And then we have CPUs, which is 4. If we said -4, then we get an error. Constraint violation, I expected this thing, but you provided -4, and this blows up on you. One of the great things about doing it this way is you get immediate feedback. Not just for, this is an int, and it's supposed to be a string. But this is supposed to be in between 0 and 64, or 0 and whatever. And you get you get kind of refined validation errors built right into the language. And then the memory is 4 gigabits. The health checks, I want 1 health check, where the port is 4050, type is TCP, the interval is 5, except 5 doesn't make sense in this case. And we'll say health check every 5 minutes, which is actually kind of a crazy health check number, but anyway, we'll go with it. And then, now that we have this, screen is a little constrained, but I can use the Pickle CLI, and I can eval this, and I can get, I end up with almost exactly the same YAML. I have one more machine to go. So this other machine is almost the same. So I'm just going to go ahead and copy and paste it. And the only difference is the region is US East. And then the environment variable is also calculated in terms of the region in this case. So we'll eval this again, and now we get the same input. So these two YAML files are structurally the same. So this is what it looks like to write it in Pickle. But we can actually do a little bit better than this. Like I said, both the US West region and US East are almost the same thing. So again, we can use amends as a way to simplify and help ourselves a little bit. Because when you amend, you say, I'm like the parent object, except with these things. So in this case, I'm going to go ahead and create a new property. Here I'm saying it's local. I'm creating a new local property of type machine. And I don't want the region here because it differs from my 2 downstream things. And then the environment variable's also different. But in this case, we can actually already use it. And later when we amend it, we render in terms of what we're amending. So we can, so later, go ahead and do that now. And this is, the syntax says amends, but this is an amends expression. When you have base machine wrapped with parentheses and then an object block, you're saying this object is just like this guy, except the region is US West. And we can do the same thing here. This object is like the same guy, except the region is US East. And we'll go ahead and eval, and we get the same error. But I kind of want to show what it looks like to make an error. So I'm gonna make an error here, and then if I make an error, then I get some helpful message saying this didn't make sense, and here's where the error is. So that's part one, and then I'm going to move on. Any questions about this? Anything that's confusing? Man, awesome. All right, so we're going to move into kind of a real-world scenario. So in this case, I'm going to show what it might look like to use Pickle to configure something with Kubernetes. So here's part two, and within part two, I have a file called Pickle project, and I've declared two dependencies. And these dependencies are packages that are published to package.picklelink.org, and by the way, you can create your own packages and publish them at will, and that works super easily. So anyway, I have a Pickle project with two dependencies, Kubernetes and Prometheus. And then here, I've filled out the schema. I've defined the schema for my configuration. In this case, the schema has Prometheus as a property to fill in. But we've defined some things that are defined in terms of Prometheus. For example, we have a config map and we have a deployment. If you're not familiar with Prometheus, it's kind of like a metrics thing. It's a bunch of things, but one of the things it does is it's a scraper that you can deploy somewhere, and it can scrape metrics and send it off to some server. And one of the ways that you can deploy a scraper is you create a deployment, and then you create a prometheus.conf that configures the scraper. And then you deploy it, apply it to Kubernetes, and then you have your scraper running. So that's what we're doing here. We're creating a config map and a deployment. But we're defining the config map in terms of Prometheus. So the config map's data has prometheus.conf, and the value is the textual output of Prometheus. And kind of think about what you would do if you were defining YAML. If I were to do the same thing in YAML, I would again create a config map with a prometheus.conf, but then in YAML I just have a string. And then within the string, the editor just says, "This is a YAML string," and you lose context there. You don't know that this is a prometheus.conf. In Pickle, we can kind of go the other way around. We can define an abstraction that says, if you want to deploy Prometheus, this is what you define. You define the Prometheus configuration, and then I'll take care of everything else for you. So we've defined the form, and now we can fill out the form. So here's, again, another file. It amends Prometheus deployment, just like we did earlier. And then we can start filling in the form. In this case, we are creating a Prometheus scraper. So this needs some script configs. And we'll go with Kubernetes scrape configs. And let's see, this is of type listing of Kubernetes SD config. It's a listing, and so I need to put things inside. Here's the thing I'm putting. Let's continue filling this out. What is namespaces? Namespaces is a namespace spec that takes names. So takes names, and we'll go ahead and scrape foo. Anyway, this is not important. I kind of just wanted to show what it's like to use Pickle. Kind of compare this to what it would be if you were writing something like YAML or JSON. that would probably look like you having a browser window open and then looking up documentation. And the cool thing is, because it's part of the language, it's part of the API of this config object, and it could just look it up just like I would if I were using, if I were writing Java or Swift or something. Now, we'll go ahead and Pickle eval this. And we have an error. I didn't expect this, but I kind of like that this is happening. Okay, so there is something about my config that's invalid. What's invalid about it? The scrape config needs, the first scrape config needs a job name. Okay, so this needs a job name. And again, this is called foo. Okay, and now it works. So, like I said earlier, what we're doing is we're actually deploying two Kubernetes resources, but as a user filling in this form, I didn't have to care about that. All I care about is what the Prometheus scraper looks like. And then I kind of want to take this concept and go even further. How are we doing? We doing okay? All right. Okay, part 3. So now we have this concept of we create these abstractions, and we use that to deploy to the external system. So let's keep going here, and I'm going to show you what it might look like to use Pickle to deploy. We'll stick with the Kubernetes theme, and we'll stick with Prometheus. How you might use Pickle to manage a large-scale Kubernetes deployment. With Kubernetes, often what you do is you don't just deploy to a single cluster. You deploy to different clusters all over the world. And so what I have here, part 3, by the way, imagine that's the root of a repo. And within part 3, I have top-level directories called production and staging. And within production and within staging, I have US East and US West. And what we're doing here is we're using the directory structure to manage the complexity of our config. So here's kind of the same abstraction. Again, it's a Prometheus that you fill in. I've added a little bit more things here. I've added resource requirements and the version of Prometheus that we're deploying, and then we end up deploying exactly the same thing. And this is how you might use this template, this form that I just defined. I do exactly the same thing. I create a file that amends it, and then I can fill it out. In this example, this is a Prometheus that's deploying, but the difference is it's deploying version 10. And then I can also say, oh, in US East, specifically, we want to change Prometheus in this way. And because we're using the directory structure in multiple files, we can put the things that have to do with production in US East in this file specifically. And we could put things that have to do with US West and US West specifically. So imagine you're a team, you're doing red-blue deployments or something, and you want to deploy version 10, deploy that and have that go up for a little bit of time. Then you just come here and you say version 10, and then you apply it. Notice this file starts with amends ... What that means is amends is that the thing where it means I am an object like this guy, except with these qualities. And in that case, this guy, what ... means is the file with the same name, the first file with the same name in the directory ancestry tree. So it just goes up until it finds another file with the same name. In this case, so you will go ahead and follow that, and that comes here. And this is another file that also amends ... and this says the resource requirements for all of production should have 10 CPU, 10 CPU requests and 8 gigabits for memory. And then if I wanted to change something that affects all of production, then I just add that here. And as you separate things into multiple files, then it becomes really easy for you to figure out where is that complexity managed. Does it have to do with production? Okay, then I just go to production / whatever. In this layout, I have Prometheus that extends component. And component, in this case, is a building block to build a logical set of Kubernetes resources. So another component could be deploying Redis, for example. It could be deploying your bespoke application. And this model lets you come in here, create something that extends component, and just define the knobs that you care about for that thing. And then again, we'll go ahead and eval that. And we get the same thing. we once again get YAML. And if I wanted everything that had to do with production, then I can shell glob that, and I get all the production stuff. So that's part 3. And so far what I've talked about is how you can use Pickle to target external configuration. And that's just one of the ways that you can use Pickle. If your external system doesn't know how to speak Pickle, then you can use Pickle to render a format that that thing speaks. For example, Kubernetes doesn't know anything about Pickle, but that's okay because we could just render that into YAML, which Kubernetes does understand. However, we also provide libraries for languages. For if you're creating an application, you can think of Pickle as just a library. And we maintain libraries for Swift, for Go, for Java, and for Kotlin. And then we have an extension point, and we have an amazing community that's provided a bunch of bindings for a bunch of different languages out there. So I'm going to go ahead and clear that. And I want to show what it might look like. I'm going to pick on Java in this case. If you're a Java developer, this might look familiar. I have a build.gradle. And then within the build.gradle, I have the Pickle plugin. And then I'm using the Pickle plugin right here, Java code generators. This is interesting. So within this application, I have source main resources and source main Java. And if we go into source main resources, I have yet another template. But in this case, this describes the config of my application. Here we have defined the host, the port, the databases, and that's a listing of database connection. And then I've defined a Java code generator, and I'm going to go ahead and run that. So I'm going to call Gradle. Oh, GW, people might not know what that is. Config classes. So I'm running a task that takes the Pickle source code and it turns it into Java. Now that I've run that, I now have Java available. So this is the same structure. This is the same thing that we've just described in Pickle, except it's Java. And now, in the actual application, I'm using the library, the Pickle library, to evaluate that file as a Java class, as an instance of a Java class. And that's here. So that looks like this. It uses the config evaluator, calls the evaluate method, and then it converts the result into an app config. And down here, we're loading the app config in my main function, and then I'm just printing, and this is a demo anyway, so it doesn't actually do anything except for printing the line, but let's go ahead and run it. And here we go. So this is the result. Indeed, it is listening on localhost 10105, except it's not, but don't worry about that. So what this means is, in Java, you also get type-safe config. You don't need to worry about what the properties are. You don't need to call .getProperty and cast it to a string, and hopefully it works, and hopefully somebody didn't misconfigure it. Because in Pickle, that's type checked. If this evals successfully, you get valid data. And then in Java, you get type-safe accessor. So you have .host and .port, and then if you call a wrong property, then you get a compiler. Pickles.
You end up with a Java instance with the correct, of course, yeah. So that we capture.
I could just repeat the question.
Yeah, sorry. So just to get it straight, so you end up with an instance of a Java class that contains the actual configuration.
Yes.
Okay.
Yeah, that's just a Java Pojo.
Yeah. Okay, thanks.
Yeah. So Pickle's power is it can meet you with your needs as first-party config and as third-party config. And Pickle is just one logical application. It's one program. And for example, what this lets you do is you can manage your infrastructure in Pickle, and you could eval the same stuff directly in Java, so you can make sure those two things don't go out of sync with each other. And because it's one language that you have to learn, you can manage all the complexity of configuration directly in Pickle, rather than spread it out in different places. And that's kind of what we hope Pickle becomes. We really like it, and I hope you like it too. And yeah, we're just getting started, and and that's the end of my demo. So if you want to get involved and learn more about Pickle, here's some things for you. Our website is picklelang.org, and on there you can learn all about the language. There's a tutorial that you can go through. There's a language reference, and then there's links to all the libraries and all the things that we do. If you want to get involved in development of Pickle, please do. We love pull requests. We love our contributors. It's at github.com/apple/pickle. And then we also have an awesome community of users already. You can go to pickle.community. This is not managed by us, by Apple. This is maintained by other people. But on there, you can find a Discord, and some of the maintainers hang out on there too. And that's the end of my presentation, but I'd love to take some questions. Go there first. Oh, you can manage.
First, thank you for the presentation and the demo.
Yeah.
I was wondering, these pickles are really well suited, I think, for distribution throughout an organization. Is there any mechanism that is supporting that?
Is the question how do you distribute
for instance,
Pickle?
you don't want to copy files, but you want to make maybe reference to a library that contains any Pickle files.
Yeah. So earlier I showed a Pickle project file with dependencies, right?
Yeah.
So those dependencies are called packages, and you can create your own packages and publish them anywhere you want.
But there is no particular format.
Oh, there's a format. Yeah. So you'd use the CLI to publish, to create packages. Yeah.
I'm just curious if you could talk about like some design goals of this compared to like CDK and the like AWS constructs library, because it feels like there's a lot of similar goals, but I'm sure that you have some different ones in mind as well.
So CDK is focused on like a particular use case. Like CDK is meant for describing infra, and what I believe it's just like that's AWS, right? Or just
CDK is, but it's built on a library called constructs that's more general.
got it. Yeah. So maybe the bigger question is, I've described these things where you can use a programming language for config, but there's also libraries that use Go or Python or TypeScript as a DSL for config. And so like, why would you use Pickle instead? That's a good question. I think one of the reasons that you would use something like Pickle is because if you have a polyglot organization where you have developers that use Java, that use other things, and you try to convince them to configure Java, why don't you use the CDK in Go? That's going to be kind of a hard sell. I think another thing is, unlike like Python and TypeScript and other languages, Pickle's designed for config, and so it has a lot of things that are lacking in those languages. And it's purposefully lacking things that are available in those other languages. For example, I showed type constraints. This is a port that should be between 10 and 63. Like you could describe that in Pickle, and the type system understands that, whereas TypeScript doesn't.
I think you talked about publishing packages and having a repository. Are there well-known packages to define things for, like, I know I've had to deal with envoy config, for example. Mm-hmm. Is there something that predefines all the types that I can just reference and then navigate through and understand how to configure it? Or
yeah, so we maintain packages, and we have like a doc site that you can go through to look at all the packages that we maintain. And then we also have code generators that take, for example, JSON schema. If you have schema already written in JSON schema, you could just generate Pickle from that. Yeah.
I think you just answered my question.
Okay, cool.
One more question. I think this last question. Sorry.
You might have already answered this, but I'm just curious if you can talk a little bit more about something like Pulumi and what are some reasons why someone would use Pickle over that.
To the first question, which is, why would you? Sorry about that. All right, I'll just hold it. So that I think that relates to the first question, which is, why would you use Pickle over Python or TypeScript? Which is, Pickle is a language designed for config, and it has a lot of features that don't exist. And then it's also a lot more portable. Like, if you're a Java developer, you're probably not going to want to use Pulumi to configure your Java app. Pulumi also, by the way, is also multiple things. And it's like SDKs plus the Pulumi engine. And so, like, it's kind of apples to oranges, and you can use Pickle to configure Pulumi too, because they have a YAML spec. I'm told that's the last question.
All right, can we give another round of applause for Dan?